Hello, today I will present our thesis, Trimming, Ordering, and Similarity Check for DSMGA-II, DSMGA-II-TOS. This presentation introduces three improvements for DSMGA-II. The dependency structure matrix genetic algorithms 2, DSMGA-II, is one of the state-of-the-art model-building genetic algorithms capable of solving combinatorial optimization problems by exploiting the underlying structures of the problems. The linkage model generates a series of masks for trial to recombine genes among chromosomes via optimal mixing. This thesis proposes three improvements that adaptively adjust the scope, the order, and the receiver of trials, specifically the mean of the mask sizes from previous successful recombinations is used to limit the maximum sizes of later trials. Also, successful recombinations prioritize the corresponding mask sizes of trials. Finally, recombinations are confined between chromosomes that pass the proposed similarity check. In this section, we propose our first improvement, the trimming technique. The trimming technique set an upper bound for the mask sizes to avoid trying larger masks that are not likely to succeed based on previous mixing. We compute the mean value of the previously successful mask sizes and set the value as the upper bound for later mask for trial. For example, suppose the successful mask sizes are recorded as the figure. The height of each vertical bar represents the size, and the trim parts are colored gray. The average sizes from the first half generation is 7 and is used to trim any mask whose size is larger than 7 in the second half generation. From this, we can further trim large masks that are not likely to succeed based on previous mixing and thus avoid unpromising function evaluations. In this section, we propose our second improvement, the ordering technique. During the restricted mixing process, a series of masks are trialed. In the DSMGA-II-E, masks are trialed from the smaller to the larger. However, there are some mask sizes that are more likely to succeed in mixing. Therefore, we propose ordering technique based on success frequency. We count the number of successes of each mask sizes and trial the ones that are more likely to succeed. If two masks have the same success count, the smaller one are trialed first. We also reset the count every generation to focus more on the recent state. The figure illustrates the idea of ordering technique. The success at mask of size 3 increases the count of the corresponding mask size by 1, and the mask sizes are trialed according to the counts. In this section, we propose a third improvement, the similarity check. In binary combinatorial black box optimization, some problems have complementary paired optimal solutions. Since the population has a tendency to converge to each optimal solution, the population guided by the fitness landscape will converge to both the complementary optimal solutions. We propose a similarity check to prohibit chromosomes from different subpopulations being mixed with each other. We define two chromosomes to be similar if their Hamming distance is smaller than or equal to half of the chromosome length. In addition, we make a restriction on the mixing such that given a receiver, only chromosomes similar to the receiver are candidates of the donors. We experiment on the following 7 test problems to verify the effectiveness of the proposed 3 techniques. From the experiment, the TOS version outperforms the original DSMGA-II-E, particularly in the folded trap, spin glass, and max cut problems. Experiment shows that our method scales perfectly as well. We propose DSMGA-II-TOS featuring on 3 improvements over DSMGA-II by adaptively adjust the scope, the order, and the receivers of optimal mixing. Empirically, DSMGA-II-TOS consume fewer function evaluations than its predecessor on most of the test problems. Thank you for your listening and have a good day.